dilation. Did I say that already? Were you listening?
Yes.
Who said yes?
Me.
No, you said.
We've got a dilation, which means when things dilate, when you go to the eye doctor and he dilates your pupils, he makes them, the thing makes them bigger. And a contraction, we're not talking English here, contraction is to make smaller. Okay, dilation means expanding, contracting means getting smaller. Okay, now look at page 345. With me on 345. Yes, Mr. Hong, we all. Question number 8 says, on a coordinate plane, draw a rectangle ABCD with A at 6, 4, B at 6, -2, C at -2, -2, and D at -2, 4. Somebody read that off for me. What was A again?
6, 4.
6, 4. B was?
6, -2.
6, -2. C was?
-2, -2.
And D was?
-2, 4.
-2, 4. Okay, that means we are going to draw this shape with those points there. 6, 4, here's 6, 4. 6, -2 is right here. -2, -2 is right there. Whoever grabbed the ruler, that's a good idea. -2, 4. You want a straight edge or something to draw something straight with. Rocco, are you with me here? Because I don't see any of that on your paper. This right here, ladies and gentlemen, is your paper. You should have the exact same things written in the same places that I do. You should have that rectangle on your paper. Please draw it there. If you want to do it in a different color, that would be just something that doesn't go in there so much. Get that written down. You should have all this here. And now it says, Sage Hyde on problem number 8. Then draw its image, and then it says A prime, B prime, C prime, D prime. That's what this little mark, when we call it, when we put it up there like that, it's not an exponent of 1. It's just a different way to mark to show these, but it means A is going to correspond to A, B is going to correspond to B, but I don't want to use the same letters because they're not going to be the same points, but I want to show that they correspond. So I put that little prime, little mark up there, it's called prime. What does it say the scale factor is, Johnny? Okay, it says 1/2. When it says a scale factor of 1/2, okay, a scale factor of 1/2, that means you multiply, factor means to multiply, all of these numbers by 1/2, or just cut them in half, would be the same thing, to get your new points. Okay? Somehow I think Jeremy and Lucas together might be a bad idea. No? Yeah, there you go. Buffer zone, we call that. So what's my new A point going to be? Half of each of those numbers would give you 3, 2. Half of those two numbers would give you what? 3, -1. Half of -2, -2 is -1, -1. Half of 2, 4 is -1, 2. Those are going to be my new points. Now let me tell you, is this going to be a dilation or is it going to be a contraction? Is my shape going to end up bigger or smaller? Nathaniel?
Small.
Smaller, because you're multiplying it by half. You're cutting it in half. So I'm going to draw my new points. And put my new point and see what happens here. 3, 2 is right here. 3, -1 is right here. -1, -1 is right here. And -1, 2 is right here. And I am going to make a nice, solid, dark line for that as well. Love it. So hopefully your rectangle looks very much like my rectangle. We should darken it up a little bit, but you're probably good, I suppose. Let me see your thing there. Okay, now I'm going to try to stump the 7th graders. I'm going to do my best. Do my best to stump you. I'll catch you on this each and every time. Every time I will catch you on this. If you look at the original rectangle and the smaller rectangle, the area of the smaller rectangle would be what part of the area of the bigger rectangle? How do they relate? The area of the small one is what part of the area of the bigger triangle? Nathaniel Lick, I think you might have said it.
Half.
I got it. I got Nathaniel on that. It is not half. Emma? 1/4 is the correct answer. Okay, and here's why, again, we talked about this. It's a tough concept to come up with. Okay, it's a tough concept. Okay, the sides are all 1/2. But when you talk about area, you're talking about multiplying 2 of the sides. What happens when you multiply 2 1/2s together? If this side is half smaller and that side is also half smaller, you multiply 2 halves together, you end up getting 1/4. Let's look at the area because Emma Christ does not believe me, nor does she understand. But that's okay, because most people don't. You just have to take it for what it is. What's the area of the big rectangle? Let's count the sides. How many spaces is this? 1, 2, 3, 4, 5, 6. This is a 6. This is a 6 by 1, 2, 3, 4, 5, 6, 7, 8. This is a 6 by 8 rectangle, which means its area is, big rectangle area is 48 square units. What's the area of the small one, you might ask? Well, let's see. What is it? 1, 2, 3 by 1, 2, 3, 4. Area of the small one, it's only 3 by 4, so it is a 12 square units. And 12 is 1/4 of 48. Because when you talk about area, you're using double the measurements. You have to double whatever. If it gets bigger by, if each side is twice as big, the area gets 4 times bigger, because 2 sides that are double as big. This is the part where you or just say, I still don't get it. Perfect. Thank you for one of those things there. And that was question number 10 there. What fraction of the area of A, B, C, D is the area of A prime, C prime, D prime there? Let's see, what else do we got there? By the way, both of these rectangles, and anytime you do dilations and contractions, they will be similar. If you like that right there. Yes, Jackson?
So the smaller rectangle, it will always have 1/4 of the area.
No, it was only 1/4 because of our scale factor of 1/2. Okay, if our scale factor was 2, then the second one is going to be 4 times bigger than the first, because you double whatever this is. You actually square it. You don't double it, because it's 1/2 times 1/2. You know, if your scale factor was 1/4, the area of the new rectangle is going to be 1/16. It's gonna get really small because you're cutting each side, you're dividing each side by 4, there's 2 sides that get cut by 4, so you're really cutting the area by 16. More than half of it.
So what if you like have 2 different like things, like say you have 6, 3, and then you have like 2, 4. How would you do the half for the 6, 3?
Well, you could put a point at 1.5. You'd have to guess where it's
And
at.
then would you have to put the thing in the middle then?
Yeah, of the lines where it goes. Yeah, yep. You could do it. I don't think they'll give it to you there. All right. Let's look at problem number 14. I want you to do problem number 14 right now. Unfortunately, this is going to go away when I do this. No, there, yes, it is. Oh wait, maybe not. Maybe I can do this. Oh, I can't. I want you to do problem number 14 right now, right where you're at, right where you're sitting.